he says, "Do you have a drill?" I said, "What do you mean?" He says, "Well, I have to drill some holes to put some eyelets in these panels." I said, "I'm trying to teach you how to plate." He said, "Do you have a drill?" And I had a Sears Roebuck bench press. So I threw it in the back of my truck and drove it over. We took it up the freight elevator and eyeballed the holes, drilled the whole tooling holes, and took the drill back home. That's how things were made those days.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson, and today I'm very happy to be speaking with Gene Weiner. You can contact him at his consultancy, Weiner International Associates. For those of you who have been in the industry for quite a while, you may know Gene Weiner, and for those of you who are new, Gene Weiner is someone who has a wealth of experience and a very long and illustrious career, so I'm very happy to be talking to him today. Gene, thank you so much for joining us.
Oh, thank you, Zach. It's a pleasure to be with you. It's, I don't know about illustrious, but it's sure been long.
Well, you and I talked about your background, and you sent me some notes as far as how far or how long you've been in the industry, and I felt that it was quite illustrious, especially some of the things that you've accomplished over the years.
Yeah. Well, I've been lucky to be in the right place at the right time, it seems, as the change was happening. And believe it or not, I started in this industry in 1956 when I was at Tufts University. I was a student technician at MIT Lincoln Laboratories and wound up in a group that was making thin film memories, additive printed circuits, 3D printed circuitry, and so forth. At that time, we didn't have copper-clad laminates. We had copper-clad phenolic, or as we called it, triple XP.
You just brought up 3D printing and additive. I think most people would find that to be maybe a more recent advance in manufacturing and especially in electronics, but you guys were doing it back in the 50s.
Well, yes, we were. I had a great boss at Lincoln Labs, Al Goodis, a very creative guy. And at that time, we were building the memory system for Sage System and DoLine, and it involved hand wiring XY drive and inhibit through ferrite cores, which was the memory of the computer. And he had the idea that we could make an additive circuit. We could encapsulate the cores in punch phenolic, protect it with Silgard, a silicone material from Dow Chemical at the time, metallize it, and then metallize it, put photoresist out. At that time was called Kodak photoresist, and expose XY drive and inhibit down through the holes on both flat surfaces by projection printing, and then etch it. And we did. It was a totally additive silver. Followed by copper, followed by electroplated copper. At that time, the metallizing was done by something called the Brashear process and was used to metallize buttons and other plastic objects at the time, and we adapted it to make a printed circuit. It worked so well that we actually demonstrated it on WGBH TV. I think it was in 1957 or 8, public television.
If only there was footage of that to put on YouTube, that would be pretty interesting to see.
It's long before YouTube.
Oh, of course, and but it was broadcast on TV. I mean, that's still really interesting. And
yeah, it was an interesting period. It was also the time of the first artwork was made at the time by hand taping on plastic and photo reducing it with a giant brown camera down maybe 10x photo reduction. And again, this Mr. Gooditz said, why can't we just, instead of photo reducing, just draw it with a head mill? He took a hypodermic needle, put a xenon point source at it, and put it on the mill and programmed it to run the circuit onto Kodak negative photoresist, film, I should say, to form a mask. And then with the negative, we had a positive, and that was probably way long before Gerber and everybody else. I know it was before Dr. Gerber came along.
Right. Yeah. Long before UCAMCO.
Oh, yes.
Yeah.
I remember when UCAMCO bought the Gerber thing. Okay. Mm-hmm. Sorry.
No, that's fine. So I think at the time, that was really cutting edge stuff in the 50s and then going into the 60s. What got you into it at that time? What caused you to go down that path?
Well, a bit of good luck, I guess. I was going to be a physicist. I was captivated by the Millikan oil drop experiment in intermediate physics, and how this guy, with really primitive equipment, could devise an experiment with mist and oil that would allow you to calculate the charge of a single electron and never missed. And I said, "Oh boy, this is for me." And then when I wound up at Lincoln Laboratories, and uh, I kept getting scholarships for chemistry and other things, so I wound up in the chem lab instead, and I wound up making the printed circuits. I was plating, I was etching, I was using photolithography, and along came a guy named Charlie Shipley, who formed the Shipley Company, who came from Farrington Industries, and developed a product that allowed you to you use electrous copper on a drilled board. And now G10 was coming along, epoxy glass at this point, towards the end of that period, the late 50s, and metallize it without sanding off the copper deposit. So in the old days, the copper would come down, was produced by Sierra Copper Gold or Atkinson. These are the two companies, but it didn't stick to the copper cladding. And he developed a colloidal catalyst. At about the same time, photocircuits developed one in house, and it just changed the industry. And after I went up, I used it for 2 weeks. Called them up, went over and asked for a job. I said, "This is going to change everything," and it did. And that moved me out of the laboratory into the printed circuit business.
So, what was the printed circuit business like at the time? I mean, this is after the war. It's still the 50s. I'm sure there's still a level of industrialization that's happening.
It was. They were startups primarily in the Northeast, with Electrolab and LFE in Boston. I remember Jim Penny and Tad Navoid Electro Circuits up at Lowell. Photo Circuits down on Long Island. Stromberg Carlson came up. Then out on the West Coast, we had Autonetics, part of North American Aviation. We had other shops starting up in Arizona. It was before Continental Circuits, down in San Diego, General Dynamics. It was IBM and Endicott, IBM at Poughkeepsie. There were a lot of captive operations. Motorola wound up getting 5 shops scattered around, including Phoenix, Arizona. I remember that one, 56 in McDowell, as well as several in the greater Chicago area. So it was primarily captives and a few smaller individuals venturing into trying to make printed circuits, including 2 former presidents of the IPC. One was Peter Sharmanian, who wound up as a president of the IPC. And Peter started in Roxbury, Massachusetts, on the second floor of an old rickety building there. And he called me up one day. I was trying to get him to buy Shipley Electros Copper, late 50s, 59, I think it was, 1959. And he said, "Do you have a drill?" I said, "What do you mean?" He says, "Well, I have to drill some holes to put some eyelets in these panels." I said, "I'm trying to teach you how to plate." He said, "Do you have a drill?" And I had a Sears Roebuck bench press. So I threw it in the back of my truck and drove it over. We took it up the freight elevator and eyeballed the holes, drilled the whole tooling holes, and took the drill back home. That's how things were made those days.
Yeah, forget about CNC. It was all by hand.
Well, the first ones had paper tapes that made a mess with the paper punching out as they run through them before we had programming totally electronic. They punched
That's
tapes and ran it through the machine.
That's so interesting because I think we take for granted the level of automation that has progressed over, that time period until today. And then if you look at processing as it's done today, at least here in North America, I don't even think we're at the same level where we should be if you look overseas in Asia.
Well, what happened was about 1975. Uh, the Japanese had come along. They were very aggressive. They had Dr. Deming teach them about quality in the automotive industry, and the electronics industry picked it up very quickly. They were very creative. They developed advanced processes. IBM set up over there. They were so good. Hitachi and others, Sumitomo, and they were doing flexible stuff. They were doing rigid stuff. And they kept it to themselves. They were developing processes. They were developing equipment. They were developing specialty chemicals. And at that time, IBM went over there and they had a 44-layer board made in their shop in Japan. Couldn't be made in the States. Then the people in Hong Kong were very aggressive. Said, "Oh, we're going to get into this printed circuit thing." And they started up about 1975. And from there, it went up into Taiwan. And Singapore had some. And some of the big guys in Taiwan were just out. In fact, Happy Holden, whom was one of your guests recently, went over there for HP to teach a company, which later became Nanya, one of the world's largest, how to make printed circuits. And the guy he trained wound up and just 2 or 3 years ago retired as the vice president of Nanya for substrates for the advanced factory, which he built in mainland. Quite a change. But then as it progressed, Motorola pretty well submarined its domestic forces set up over there. Then they developed a mezzanine buried capacitor board made in China. Then other people, then Intel wanted to have its substrates and boards made over there, and they actually sent 40 engineers to Taiwan to improve the yields of Compaq and of Nanya so that they could meet the Intel standards. So they, in essence, taught them how to put a quality system into advanced boards, or at that time, advanced boards are 10 mil line in spaces and so forth, not like today's. But it really was amazing. And then everybody followed. I remember talking to the purchasing manager of an outboard motor company. They built Mercury and the others there. And they said, "What's this going on in China? All my friends at the club, other electronic guys, are now buying the boards in China. Do you think I should?" I said, "I'd hate to see it. Are you interested in price or what? Because in China, you're going to be dealing with new issues again. You're going to have a quality issue. You're going to have a time lag issue. And all that happened. But they learned pretty quickly. And they came up. Taiwan got pretty good on quality. China came along afterwards. Chinese started reverse engineering everything, copying things. And as we shifted things overseas, a lot of Japanese guys weekended it in China to teach them how to do things. And then Americans started getting hired over there. And people just didn't want to pay the price for a quality domestic board when they could buy something, and the major companies, Burroughs and IBM and HP, all killed it for a much cheaper price, much lower price. And it was price, price, price.
You mentioned earlier that Motorola had captive operations, and Happy had mentioned that HP had their captive operations, and a lot of other companies had captive operations.
Yes.
And when you then look overseas and you bring up like Nanya in Taiwan, and I'm sure we could run down a list of other names that were operating there at the time, it seems that there stopped being an interest in improving local or captive operations and just improving it overseas.
Well, the OEMs at one time did an awful lot of research here.
Right.
Motorola did, IBM did. They did great jobs there. HP, General Dynamics, they all did great things. However, the cost was so attractive, the cost reduction, that they just said, "Well, we'll do it, and we don't have to do this." And then eventually the margins get squeezed. And so when the margins get squeezed, they didn't want bricks and mortar. They just wanted the intellectual property. Then eventually it's got squeezed so far they stopped doing the R&D and left it up to the guys building the boards and the supply chain, which were the specialty chemical guys and the laminate guys. And equipment guys, of course, and software people. So what were they left with? Then you can eventually had ODM, jobbing out the design. I was involved in the board of a company where a good number of our jobs were involved in. We were given a part and say, "Can you design and build this for us? Not just build it to print, design and build." And that came along. And then eventually some of it went to box build, but not that much yet.
Well, I see two parallel themes here. One of them, I think, makes a lot of sense, which is that specialization in that type of service or that type of labor, which is specialization in manufacturing. Because before that, when everybody has a bunch of captive operations, as individual companies make an advance, it's almost like everybody else has to come back and reinvent the wheel. So it kind of makes sense to have these contract services that are just good at manufacturing. But I think what's interesting is the fact that none of them were developed in the U.S. It all sprang up overseas, and we've kind of been following ever since.
Well, there was also a culture difference. The governments of Taiwan and of Hong Kong and of China uh, created great incentives for the companies to go into this and invest in this and build this. And we created great taxes as they were creating incentives. And the government policies have been consistent. Very few regime changes. Even when the governments changed in Taiwan, there were still itchy Urso, the government-sponsored R&D things to which companies could participate. And if they participated in the programs, they got a pretty cheap license to produce it in the country for the country. And when companies went there, if I wanted to set up a factory in Hong Kong or in Kaohsiung or something, I might be given 5 years tax free. This happened in Kunshan in China. The mayor and the province, down in Canton province, created tax-free benefits for so many years, which lured companies from even from Taiwan to build their factories in mainland China, to which a substantial part of Taiwan's production, company's production, is in China, but rapidly moving to Thailand and Indonesia now. I wish it moved to Mexico and Europe, but Thailand is the big recipient at the moment.
So that's interesting that you bring up Latin America because just recently we were talking with another guest, Case Engelin, and he's from Titoma, and they're a smaller manufacturer, but they work in Taiwan and China, but they also have a plant in Colombia. And so I was, pretty surprised by that because, for a smaller company to go into Colombia, I think is rare. But now a lot of companies are looking more at Latin America and specifically Mexico. And what do you think the momentum needs to be, or what do you think needs to be done to maybe encourage companies to broaden the base a little bit into those other areas of the world?
Well, I hate to say it, but the geopolitical situation and the cartel situation has to be sorted out before it's a big rush to Mexico. I think Mexico is ideal with the new U.S. Mexico Canada alliance and the advantages that it provides to all three countries, particularly with the new joint thing announced by the president this week with Canada for printed circuits. Mexico is a prime target. Mexico is booming. It's everyone thinks Guadalajara and the hundreds of companies there. There's more than that. There's an aerospace center called at Querétaro in Querétaro province. 2 million people, 5 or 6 universities, international airport, good security. A lot of the big players are there. Samsung Aerospace companies are there. Even a Hong Kong owned company, which is a Bermuda corporation, Bermuda registered, set up an EMS company there. And EMS will be probably be growing there. And it's been growing 5, 6, 7% a year, but probably 18 to 20% a year in the next 5 years if they could get uh, the political situation sorted out and get the cartels under control. But even so, Querétaro and Guadalajara are safe. They're global centers. But what's missing are the printed circuit shops. What, 2 or 3 in Mexico? And you still have the 10th largest thing there. They still got to buy the boards from Asia, or certainly not the U.S. We don't have the capacity. We no longer have the capacity. We have companies that can't even get people to quota jobs in the U.S. on conventional circuit boards, single, double-sided, 4-layer, 6-layer type things. So, but the next problem is water. Now,
Really?
printed circuit fabrication requires a lot of water
Sure.
for plating, for rinsing, for etching. We need water. And Mexico's a dry country. It's an arid country, and there's a water shortage. The solution to that's fairly simple. There are tens of thousands of desalinization uh, factories, plants along the shore, like near Guadalajara, producing water for whole countries in 17, 18, 19 countries that can be licensed. Every nuclear sub or aircraft carrier makes its own water for months, and it's now a modern, affordable technology. Plus, with the developments on waste treatment and processing by guys like Alex Stepinski, who put in the green circuits up at Wayland, up in New Hampshire, you use much less water. You recycle a lot more, and the waste is less. So I think Mexico, location-wise, is a prime target. The fact the EMS business is already there waiting, we just need the bare boards, and we should be and we have skilled labor there from the universities and from the 10, 20 years of EMS experience. It's a logical thing, except for the politics and the cartels.
Yeah, it's centrally located too. I mean, you have shipping direct there from Asia, you have shipping to Asia, you have shipping to Europe. It seems like a logical place to have kind of a second global hub for electronics manufacturing that can serve a lot of different regions of the world, but also it is maybe a lower cost option for like the United States or Canada to produce things that you could maybe say are not like critical to national security or critical IP for big companies and things like that. So I think it makes a lot of sense.
And especially since the semi-skilled labor force is available at the current
Yeah,
time.
that's another thing. I think in the U.S. we get we get a little, I don't know, maybe pretentious about the labor force sometimes, and we don't realize that there is a lot of skilled labor that or labor that can be trained up in some of these other
Yes,
countries that can
upskilled.
serve some of
Yes,
those needs.
yes, absolutely. But we have, manufacturing seems to have become a dirty word in America, and with the IPC and other groups, we're trying to educate the young people through the STEM programs and the IPC chapters at various universities and colleges. And we this year we had hundreds of kids attend the IPC in San Diego, kids, young men and women, and they had a breakfast for them. They toured, and they were amazed at looking at the equipment running on the floor. High tech stuff, software, artificial intelligence, machines talking to each other, handling parts, people, and the work is done. It's brain work now primarily.
Yeah, I'm really hopeful that more of those types of events and seeing is believing will really push kids into a career in manufacturing. Because I have to be honest, when I was younger, 20 year ago, and I was in high school, I had a job at a local cookie factory. I like to talk about this sometimes, but I mean, it was all manual. That was not something that was not a place you wanted to aspire to work in, and it created kind of this bad image that manufacturing is still a lot of manual labor, people sweating it out on the assembly lines and things like that. Like manufacturing was two options, like Intel, which was super advanced semiconductors, and then everything else which was still stuck in the early 1900s or something like this.
Yeah, you say when you were younger, Zach, you are younger, but it's all a matter of reference and from where you're standing. But again, we talk about the past, but let's look to the present and the future. There is so much going on now in automation, the use of artificial intelligence or simulation, the rapid changes, the component shortages and problems caused by both COVID coupled with the geopolitical situation has caused people to say, hey, is there another way of doing things? And the use of artificial intelligence, and as you know, as a designer know, is coming more and more into use of that for component location, selection, determination, rerouting. And my son ran into this problem. He's with a company called Analog Devices, and they ran into a supply problem on components. I said, how did you solve it? He says, we redesigned the boards, and it works for what we have to do. He said, yeah, the boards were a little larger and we had to use a few more components, but we performed the function. But now we have another situation where the government's is sponsoring and trying to incentivize more investment in chips with the CHIPS Act here. And then the government just approved this week invoking a Defense Act to get boards made here. we still have to package the chips. The chips have to be packaged. They have to go on a substrate, which has to go on a printed circuit. So if we make the chips here and the factories are done and these hundreds of billions of dollars are invested, the government's only kicking in 52 billion. That would cover one modern chip factory today and have it producing in 3, 4, 5 years if they get the equipment in by then. Um, they still have to package it, so you have to ship it to Asia to be packaged, and then where are the boards made? You still got to get them there. So what they're doing, unless they do the complete supply chain right from start to finish, they're lengthening the supply chain by having the chips made here, shipped back to Asia, then shipped back here. So we need the complete package. We need the assembly here, and we need the packaging here. We need the boards here. We need everything here. And by here, I don't say onshoring, I say nearshoring. Some of the stuff can be done with allied countries, with countries such as Switzerland, or Germany, or England, Mexico, Canada, of course, by treaty, and even Israel, which has high tech.
Yeah, so to me, it seems to make sense for broader sustainability and uh, less risk in the supply chain to broaden that capability out across US, Latin America, Canada, Europe, and even other places in Southeast Asia.
I think you're absolutely right. Just building chips in America without building the rest of the supply chain here just lengthens the supply chain. And we have two things that we need here. First, we need the packaging in the United States. And I just noticed in the news this past month that MKS Instruments, which owns Additive, set up a complete laboratory with lasers and equipment and tools and design capabilities for doing additively manufactured substrates, the ABF, the Ajinomoto builder film, for its 8,000 customers worldwide. I sure wish they had built it in the U.S., and I wonder what kind of incentives there were. Probably incentives were that everyone that does that is in Southeast Asia and is using a Japanese material. We need that in the United States. So we need a change in government to be more consistent to incentivize the private industry to invest in that. Because if you don't build it, they're not going to come. And you have to have an incentive. You have to have volume, demand. You have to need a certain amount of return for a private company to invest in it. So we absolutely need this in the United States, and I hope we can get more, maybe a tax benefit or some other thing with a friendly company that has this technology. We no longer have the technology here, but an American-owned company in Japan has that technology, and they should somehow want to bring it here. Now, what are the differences? How can we get a consistent government program to continue to incentivize this so that we have a secure private, private manufacturing facility or capability that is not at risk for not just for the defense, but for medical, for communications, for production, for everything we need here. Probably we need 5 to 6 times the demand we currently have of boards or
Wow.
capability. Because right now we're doing about 4 billion a year in the U.S. The demand to build the factories and equipment to do all this would most likely be 25 billion or more. Don't forget the world market is 80 plus billion.
Okay, I mean that's a very large market for sure. I wouldn't have expected that the amount of market that we just need domestically to even justify it would need to be so large.
Well, it may not be. That's the way I would like to see it. I'll put it that way.
Okay, I mean I can get behind that.
Yeah, that would take us back up to about, at that time, 5 years out, to maybe 25% of the world market.
But is this a case of if you build it, the demand will come? Or are these companies that need to invest in that capability and build it up, are they always chasing the demand? Meaning the demand has to be here first.
Well, this is where the government intervention or government incentive comes in. The demand was not there when they built these huge factories in China and Taiwan. They built it on the come. Now, let's say you're running a company and you want to build a substrate factory, and it's going to take $100 million in equipment. You have to wait 2 or 3 years for the equipment. You've got 5 other competitors already there or trying to set up. What will your stockholders or money people say? How patient are your investors in America?
I mean, depends if they're, depends if the company is private or public.
I, I always, it doesn't matter, private or public. It's not
I think it does
government.
a little bit.
Not. Would you buy stock in a company that's risking $100 million for one factory on the come, knowing that there are 4 or 5 competitors out there trying to do the same thing, or that are located in Indonesia or Thailand that are cutting their price, or in Switzerland?
Um,
We need a tax benefit. We need an incentive. We need something that keeps them going, like such as with the CHIPS Act. If you buy American, you get a 15 or 20% tax reduction. So that's permanent. That's long range. That's an incentive.
but now we're just copying the subsidies that got these other countries to the point where they're at now. And they're the demand, at least from the consumer side in Asia, is so weak compared to the US, Europe, and Western nations that they have to subsidize what they do in those countries in order to meet that overseas demand. They're not going to get anywhere just off of domestic demand. Those subsidies are really helping to propel those companies to the point where they can produce enough for overseas markets.
And it keeps unemployment lines low, and it
That's
keeps
true.
people working. Um, and there are a lot of ways to incentivize this and do it. But if you build it, will they come? Remember the baseball picture? If you build it, they may not come. You have to have some incentive, and I think there has to be a major incentive on the R&D side. For example, with 3D additive manufacturing, the use of AI in design and manufacture, the development of new materials, new methods of putting it together, new methods. There was a new method that just was announced that will allow the production of a 2 nanometer chip. Uh, this just I forget who did it. Somebody just announced. I saw it in the press yesterday, and so there are the R&D. I think should get more. We used to have good R&D incentives. I think we should bring them back and then some. Because if you play catch up, you don't catch up. While you're trying to catch up, the competition moves ahead. So you have to try and move ahead while you're shoring up your base while you move ahead for the future.
Well, it seems to me that companies that want to get into this business need to do what maybe Nanya did in the 80s, which is hire all of those folks from overseas as consultants and have them bring that knowledge over and hire them to build up a printed circuit or a substrate factory.
China just announced, the deputy minister of China on the current situation, that they will treat foreign technology people like natives if they come and help them with the chip business. This was announced just a couple of weeks ago. I'm not too sure that's the answer. That type of that means money is king, money talks, and money buys everything, and that's not always the case. There are other ways to incentivize people and companies.
So, what are those other ways to incentivize people and companies aside from? I mean, because if you just do subsidies, money is still king, isn't it?
Yeah, to a point, yes, but try to hire a young person today, steal them away from another company, and say, "Well, I'm not going to give you 7 weeks vacation, but I'll give you $1 an hour more." That's money. I'll give you $2 an hour more, but you can't have a vacation. $3 won't work. You have to have other things that go with it.
That's fair. That's fair, especially with the workforce. And at least here in the US, the workforce issue is so pervasive. I mean, it's like we've lost an entire generation to the software world. And I'm not saying software companies don't deserve to have talent, but it seems that for the past 20 years, they've gotten so many people, and there's been this hollowing out of the electronics engineering and design talent.
Well,
And
rather than just hire people, there's a word called partnering. How about
okay,
joining with and partnering where both sides benefit? If you can develop a mutual expectation, you will have a success. But you have to have a mutual expectation on both sides or 3 sides. And I think partnering is going to become a must, whether it be nations or companies, more than it has in the past.
These are all great points. I mean, I'm interested to see how the policy situation and the business models start to change as the ball starts to roll downhill to bring some of these more advanced capabilities
Well,
closer
remember,
to home.
partnering shares the risk, reduces the risk for any one company or person.
Sure, that's fair. I can see that.
You asked how to reduce the risk. That's one way.
That's a great point. Yeah. Well, and I think that's probably where public policy plays a role, and we're seeing that now with the national, I think it's Semiconductor Research Center or something like
Yes.
this. I forget the
Yes.
name, but there's a research center that's being built up through CHIPS Act funding,
Yep.
um, that is doing exactly this kind of R&D and having government risk the bill on it. And maybe we could see the same thing in packaging and even some of the more advanced printed circuit capabilities.
Yeah, there were a couple of companies on the totally additive manufacturing thing. As I said, the IPC put out a call for 3 different committees for this just this past week to form them. But and there's several at the IPC show. 1, 2, 3, 4 companies displayed additive manufacturing processes in part or complete. And one of them is is headquartered and developed in New York. And I'm not going to mention the name here because they'll be rushed and they may not be ready. But they've already placed a large platform into one of a remaining larger printed circuit companies for development for totally additive stuff, at least for R&D. And people say, "Oh, I heard of this company from Israel. I heard of that company from Israel. Heard of this company in Japan." Fuji introduced the system in Holland at a trade show several months ago, but we got some right here in the U.S.
Well, I think as these capabilities start to develop, it's going to be a very interesting time for domestic manufacturing, and we'd love to have you come back on and discuss it more.
Yeah, I think so. I'm looking forward to it. If I can get another 60 years in, it would be great.
Well, let's hope so. Let's hope so. I mean, your experience is so valuable, and it'll be great to see how this all develops.
Yeah, I hope so. And you can send me a message on the other side when you're my age.
Thank you very much. We're going to have to wrap it up there. To everyone that's been listening or watching on YouTube, we've been talking with Gene Weiner of Weiner International Associates. If you're watching on YouTube, make sure to hit the subscribe button. Of course, leave your comments, and you can keep up with all of our tutorials and podcast episodes as they come out. Last but not least, don't stop learning, stay on track, and we'll see you next time.